in exercise 505, we look at perimeter, and we're going to look at circular shapes. We're going to look at shapes with straight sides, or we might look at composite shapes where it's made up of partly got a curved side, partly a straight side. I'll be very surprised if you haven't heard of perimeter before. So I'm just going to go through this fairly quickly because you probably are well aware that the perimeter is the distance around a shape. And what you'll see me do, so if it was something as simple as a rectangle, you'll see me draw a little asterisk indicating this is where I'm starting, and I'm going in, say, this direction around the shape until I get back. So I'm thinking about that that's what I'm doing for perimeter, and I'm finding these distances as I go and adding them up. So for shapes with straight sides, the perimeter is found by adding together the lengths of all the sides. It's actually the same even if the sides are not straight. You still find the length of that curved bit and add it onto the straight sides. Now, the way that they complicate these situations just a little bit is they may not give you the length of a side or the length of a dimension. Now, if your figure has straight sides and the length of a side is missing, you most commonly will need to know to use Pythagoras' theorem, but you won't be told that. So this is something that really needs to go in your summary. If the length of a side in a straight figure is missing, you will commonly need to use Pythagoras' theorem. So we'll get to practice Pythagoras' theorem. If we've got circular sections, then some things that you need to be aware of are that the circumference is the distance around a circle, and the entire circumference is pi times d, or 2 pi r. So we'd use this formula obviously if the diameter was given, and this formula if the radius is given. With the perimeter of a sector, you just need to be a little bit careful. A sector must always have an angle given at the centre. That's the only way we know how big our sector is. And what we have, if we have a sector, so let me just outline this sector for you, here to here to here. Now, a piece of pie is a sector. If I only want part of the circumference, and part of the circumference is this thing called arc length. Arc length. So be aware of that. The curved bit is called the arc length. For the perimeter of this sector, we would then have the straight sides as well. So we would have our arc, we'd have this straight side and that straight side. So I would be adding together 3 things in total. One of them is calculated based on the circumference, or a fraction of the circumference. What fraction? It's this, whatever the angle for the sector is, out of 360. That's why you must be always given the angle at the middle of your sector. So that fraction of the circumference gives you the curved length, and another name for the curved length is the arc length. These are things that need to go in your points and your summary. And then don't forget, if you're getting the perimeter of the entire section like I highlighted here in yellow, you need to add 2 lots of the radius, or the radius plus the radius. There are some common sector sizes like a semicircle. So if you're given a semicircle, you know, let me just demonstrate what a semicircle looks like. So this and that, and we know that's the centre. So it's basically half the circle. So this is half the circumference. This curved bit, half the circumference. You might wonder where that half comes from. It comes from what we said here, which is angle at the centre, and the angle there is 180 degrees out of your total 360, just like the formula up there says. But 180 over 360, if you take your calculator and put that in and use your fraction button, you'll get a half. The other common one is a quadrant. So it's a quarter, and this is 90 degrees. You may be wondering where the quarter comes from. It's because that angle there is a right angle, which is 90 degrees out of 360. So what fraction of the circle is that? That is a quarter. So we only want a quarter of the circumference. Yeah, I think we've got time to do this example. So its perimeter, you can see I'm going to start here. I've got an arc length, I've got a radius, and I've got another radius. So I'm going to write that. Perimeter is the arc length. I might call it 2 times the radius, because I know that r plus r is 2 times r. The arc length. How do I get the arc length? Well, I can see this is one of the special cases. It's this case. I only want a quarter of the full 2 pi r, the full circumference, and I want 2 times the radius, which is 6. So I want a quarter times 2 times pi, and the radius is 6 plus 12. So it is 3 pi plus 12 millimeters. Now you can leave it like that, or you can go to your calculator and actually put in the value of pi, and I guess you would be rounding the answer. But if you want to give an exact answer, you leave it in terms of pi. I'm going to stop the video and do example 2 in a separate video, because I think you'll see that the need to use Pythagoras' theorem comes up in that one.